Welcome, boys and girls. Today we're talking about double replacement reactions and precipitation reactions.
Like rain?
Yes, something falling out of solution. Precipitates.
Okay.
Sure.
So
we talked about redox,
Okay.
which was single replacement, synthesis, decomposition, and combustion.
Okay.
Now the fifth one, double replacement, and we're talking about a different type, precipitation.
Fantastic. Can I just remind them that on the back of their periodic table, they need to use these solubility rules in the middle to actually help them figure this out?
Oh, they've got these memorized by now.
Oh, these are all, yeah, you guys
Easy.
got it. No problem. Okay, so but just in case, I'm just going to keep this on the side
If
here.
you must.
And so I guess the first reaction
Okay.
we're going to do.
So let's do calcium nitrate
All right. So
plus potassium carbonate.
calcium nitrate plus potassium carbonate.
Okay, so we have two compounds, and you're going to need to figure out the products and if there's a precipitate. So double replacement reactions only occur if one of the products is insoluble. So that's why these solubility rules are so important.
Great.
If they're both soluble, no reaction. Okay, so first let's break everything into our ions. So calcium and nitrate from the first compound. Calcium's +2, nitrate's -1. And then we have potassium and carbonate. Potassium's +1, carbonate's -2. Okay, so if we have double replacement reaction, what happens? Do you remember?
So that means there's a double switching of partners. So calcium's not going to be with nitrate anymore. Calcium's going to be with carbonate.
Okay. So we get
Boom.
calcium with carbonate, which leaves potassium with the nitrate. So let's write our new compounds.
Okay. So, I've got potassium and nitrate, which both are +1, so just need one of each. Potassium, nitrate, plus calcium carbonate, both +2, -2, so just one of each.
Yep. Okay, so what you'll notice is the oxidation numbers did not change.
No.
That's why the double replacement reactions are not redox reactions. So we only classify them as precipitation reactions.
Okay. If they make a precipitate, though.
Right, so if they occur.
Okay.
Okay, so now we need to determine, does this happen or not? So let's look at our solubility rules. Is potassium nitrate soluble or insoluble?
Well, okay, so I'm going to look at the anion, which is nitrate. I find it right here. Nitrates are all soluble, no exceptions.
Okay.
So this guy is soluble, so he's
Okay.
not a precipitate.
Okay, so now let's check calcium carbonate. Carbonates are insoluble.
Carbonates right here are all
But
insoluble.
there are some exceptions. So is calcium an exception?
Well, calcium, it's not ammonium ion. It's not an alkali metal, which is group 1. It's an alkaline metal, so therefore it's not an exception, making it insoluble.
Okay, so this reaction does occur, and calcium carbonate would be our precipitate, would come out of solution.
Okay. Insoluble precipitate, PPT, right, is the thing, right?
Sure.
Great. I'll just let you keep going.
So this reaction does happen. So let's try another one.
All right. What's the next one you got for us?
Okay, so let's do magnesium chloride
All right.
and sodium sulfate.
Sodium sulfate. All right.
Okay, so let's break our compounds up. So we have magnesium +2, chlorine -1, sodium +1, sulfate -2. Okay, so now we need to pair up our new compounds. So magnesium is going to pair up with the sulfate, and sodium is going to pair up with the chlorine.
All right. So that would make NaCl
Salt,
and MgSO4.
Epsom salt. I'm making lots of salt.
A lot of salt, yeah.
Okay, so how do we figure out if this happens or not?
Well, one of them has to be insoluble, right?
Okay, so now we need to check.
All right, so let me look.
Sodium chloride.
Sodium chloride. Chlorides are all soluble except if they are silver, lead, or mercury.
So
Nope,
that's
okay.
that's
So
soluble.
that's soluble. And let's see the other one. Sulfates are right here. Sulfates are soluble unless it's one of these guys. But no, magnesium is not one of those guys. It's the exception. So this is also soluble.
So we would say no reaction. This does not happen.
No reaction. That's reaction. So no reaction happens because how could you tell if it happened? They all just stay mixed together and nothing falls out as a precipitate.
Yep. So that's it. Got to remember oxidation numbers, write your products, and determine if the reaction occurs or not by making a precipitate.
I'm down with that.
Ow.
Got that on video.